So we see sample exercise 5 from our chapter on thermochemistry here. And this type of question is representative of a type of reaction that you could see in an in-person setting for general chemistry 1, where we have a 30-gram sample of an unknown solid, and we heat that in a test tube. So we get it to be in boiling water. So we assume that its initial temperature is 100 degrees Celsius. Then we carefully add this solid of unknown composition to 40 grams of water in a calorimeter. So that's 40 grams of water, 30 grams of sample. The water temperature increases from 25 Celsius to 29 0.5 Celsius, so we can calculate a delta T for our H2O, for our water. And we want to know what is the specific heat capacity of the solid, which we could use to identify the unknown solid if we had a list of unknowns and their specific heat capacities. And then we're also reminded the specific heat capacity of water is 4.18 joules per gram Celsius. So let's see if we can sort out some of this information, because we know in the end that the Q of our solid can be equated to the negative Q of the water. And that's because the water would be absorbing any heat that the solid is giving off. So we can set these values equal. So let's see if we can put the mass of the solid. Then we have mass of water over here, right? We're just kind of sort everything out. Then we have our specific heat over here of our sample. This is unknown. Our specific heat of water, we do know that, 4.184 joules per gram degree Celsius. We were told we had 40.00 grams of water, 30.00 grams of solid, and then we just need our delta T's here to set these values equal. So we had that our delta T for the water is going to be 29.5, right? Our final value, minus 25.00 degrees Celsius. So we see that our delta T here is 4.5 degrees C. So now we're going to take these values and we'll set them equal. So we have Q of solid equals Q of H2O. And over here, I have 40 grams times 4.184. If we go to another sig fig, times 4.5 degrees Celsius. And then over here, my Q for my solid, remembering that this would be negative here, almost forgot that. We have our 30 grams of our solid times our unknown specific heat capacity, so C, and then times our delta T. So our solid, the delta T for that, we started at 100 degrees Celsius, so that's my initial temperature, and my final temperature is going to be the same for both the solid and the water. So that's going to be 29.5 minus 100, so my delta T is going to be negative 70.5. So when I plug that in here, I can see that I could multiply 30 times 70.5, and that would give me 2,115 grams degrees Celsius when I combine the units, and that's times C still. Draw a little dividing line here. So that's my unknown that I'm going to solve for, that's C. And then that's equal to 40 times 4.184 times 4.5. So that's about 752.4 joules, because my grams cancel, my Celsius cancels. And now, to end up with a unit of joules per gram Celsius for my specific heat here, I'm going to divide this side by 2115 joules degrees Celsius. And so 752 divided 0.4 divided by 2115 gives me about 0.36 joules per gram degree Celsius for my specific heat. And again, if I had a list of possible unknowns, I may be able to identify my unknown.